Okay, here we're trying to minimize and maximize this function at the same time, so basically find its absolute minimum and its absolute maximum in this given region. It's not a guarantee they can always find the min and the max, but when the function is defined on a compact region, such as this one, these two always exist. The min, absolute min, and the absolute max. So, look at the function first. And note the region. This region, you can clearly see that this equation defines the interior of a circle of radius 5 together with its boundary. So this blue region is everything that we're considering. We're not considering points outside of the circle, just the circle and what's inside of it. So when we look into problems like this, there's two things to pay attention to. There's always the interior and the boundary to be considered separately. Any local maximum or minimum in the interior is a critical point of the function. So we first find the critical points. Those are candidates for the absolute minimum and absolute maximum. So finding the critical points. Gradient f equals 0 is the equation we're trying to solve. So the gradient of f will be 2x, 2y minus 4 equals 0, 0. That is 2x equals 0, 2y minus 4 equals 0. So that means x equals 0 and 2y equals 4, y equals 2. So that means the only critical point is 0, 2, which does live inside of the circle. It lives right there, 0, 2. So it is a point I should consider. If for some reason my solution gives me a point such as, 10, 0, which is all the way outside here, I do not consider this point in my list of candidates because it's not part of the domain I'm considering. It's not part of the region that I'm trying to maximize my function in. So that was the interior. That takes account of the interior. Everything in the interior, the only candidate for max and min is this guy. Now I'll look into the boundary. I need to parametrize this boundary so I can turn this function f into a function of one variable only. I can do that because that's a curve. It only has length, doesn't have area, so it only has dimension 1. So one variable is enough to describe it. So how do I parametrize a circle of radius 5? I'll call it r of t equals cosine of t sine t. That's what I'll do. So I'll say g of t is going to be f of t, or f of cosine of t sine of t. And in fact, I forgot one thing. Since the radius of my circle is supposed to be 5, the parametrization needs to be 5 cosine t, 5 sine t. So I'll rewrite that. So that's the standard parametrization of a circle of any radius, right? Just remember to add the radius here, which I did forget. So calculating f of 5 cosine t, 5 sine t, I plug that into the original function I was given. That is 25 cosine squared t plus 25 sine squared t minus 4 sine t plus 4. Those two put together equal 25 because cosine squared plus sine squared equals 1. that's 25 plus 4 minus 4 sine t. That's 29 plus 4 sine t. That's the function on the boundary. Okay? So I want to find the maximum on the boundary, or the minimum. That will also happen at a critical point, but now at a critical point for t. So I gotta do g prime of t, which is going to be 4 cosine of t. Make that equal to 0. So that means the cosine of t equals 0. What is an angle that I know whose cosine equals 0? Remember the unit circle. X is the cosine, y is the sine. Points that have cosine equals 0 are these two. And in fact, all of those points, all of those angles that can be obtained by rotating 2 pi from those, but they'll just end up on the same spot on the circle. Since that's what we care about, we only need the 2. You don't need to add plus 2 pi n or 2 pi k at the end or anything. Just the 2 points are fine. So just t equal to 45 degrees, 90 degrees, this guy, so pi over 2, or t equal to 270 degrees, which is 3 pi over 2. Okay? You can also just look and remember what that gives you. You can take the t equals pi over 2, plug it into this to find the coordinates. What you'll get are the coordinates 0, 5, right? This is the coordinates. These are the coordinates of this point. Also easy to see. And same for 0, -5. So these are the 3 candidates that we found, these 3 points in green there. 0, 2, 0, 5, 0, -5. So how do we decide which one is the absolute maximum, which one is the absolute minimum? We just plug in f, plug them into f. So f of 0, 2, first I'll calculate that. That will be 0 plus 2 squared minus 4 times 2 plus 4. So that's 4 minus 8 plus 4. So 0. F of 0, 5 I'll calculate as well. That will be similarly 25 minus 20 plus 4. So that will be a 9. F of 0, -5, that will be slightly different. That will be -5 squared is 25, and then plus 20 this time, plus 4. So that would be a 49. So out of these 3, I look at which one is the lowest value. So that means this is the absolute maximum. The lowest value is the absolute minimum, of course. And this is the absolute maximum. Now, we don't even know if this is a local min or a local max. It could even be a saddle point, but it doesn't matter. That's not what we're looking for in this particular question. So the absolute maximum value is 49. The absolute minimum value is 0.